So we are now recording, and I want to compress this in just 10 minutes. What I want to present, I just want to compress in 10 minutes. So we want to let me share with you. This is the content that we'll have to cover this second semester. The course is Stat 326 Advanced Probability Theory, and it's a core module for statistics students. So only statistics students we offer this module, and this is the course outline. So in the course outline, we are when we say advanced probability theory, is the theory of probability that we are interested in. We are interested in the theory of probability, and so we will look at it from the aspect of a theory, not actually just practically solving problems, but what is the theory behind it. So we'll talk about probability distribution. You already know one case, two case that is two-dimensional cases. We did that one in random variables, probability and random variables, where you have marginal distributions as the case may be. We also study conditional probabilities, marginal probabilities. So what is the theorem? Is the theorem, what is the theorem behind them is what we are discussing. And we'll look at also conditional variance, yeah, for continuous and discrete cases, normal distribution, normal approximation to binomial, hypergeometric distribution. We also have even a Poisson distribution, and but you will know the distinction between what is a discrete random variable and what a continuous random variable, and which of these ones will fall under the probability theory. As we go along, you learn them. Yeah. So look at Jacobian transform, the gamma and beta functions, the gamma and beta density functions. So these are density functions. These behaviors are actually like how machines operate, how human beings operate, or how um, um, maybe natural happenstances, infectious disease. These are all linked towards. These are models that you can test to see, or you can use to predict the behavior of certain things. That if this thing happen, then this how it will behave. Or like in a uniform production in a factory, when the factory is producing, definitely you see that if the factory want to produce like cold storage, want to produce 5,000 bottles of soft drink, they know exactly what is going to be their input and how they can set the machine to do this production, how many seconds it will take to produce one bottle of soft drink, or as the case may be, so that they can get their output. So look at factorial generating functions also, obviously generating functions, characteristics. So it's like negative binomial, we do binomial, negative binomial, and marginal distribution. So these are this actually the course outline that we'll be targeting, and will ensure to cover all. So just a quick, as before we end today's session, um, just a quick, the notes will be made available to you. I just want to like see that we start. When once we've started and you guys are really following the technology, I'm quite impressed that you guys are understanding. When we go along, maybe later in due classes, you will begin to enjoy the use of this type of technology in learning. Though we are also missing the the face-to-face interaction, which is quite good also, especially when we yeah. But now the so that is it. So this is just the probability theory. I'll look at the axioms. These are now the axioms. Few axioms I just discussed was that, let's say this for an experiment or an event, because probability is the likelihood of an event to occur. See, I have a coin. A coin has tail and it has a head. That's what are the face on the coin. So if I'm tossing that coin, the possible outcomes that I'll expect is either I'll get a head or a tail. So, and it's only two possible outcomes. So those two possible outcomes are elements of what? The sample space of that experiment, which is tossing a coin. And for that reason, the two outcomes I get head and tail. So the probability of that sample space is equals to 1, because I only have two elements in that sample space, and then the number of events in it is 2. So it is the 2 upon 2. So therefore, in general, the probability of all events in general, it's equals to 1. And the probability of an event must always be greater than 0. Greater than or equals to 0. It's equals to 0 if that event is not certain to happen, but it's less than 1 and what? Greater than or equals to 0. If it is 1, then that event is certain for happenstance. Okay? Then we also went on to say another theorem is that if I have events, this event could be event A1, A2, A3, continuation event A4, A5, A6. So if these events are mutually, they can be finite or infinite. If they are mutually exclusive, that is, this event is independent of this, then the probability of their union is equal to the probability of the union of A plus the probability of the union of B. That is why. That is an axiom. It's an axiom. And we have to accept it that it's a law. An axiom is a law. Okay? So as I said, this is a start. We're starting today. I will strictly go by the timetable, which is the timeline. And I want you also to endure so that you can get more knowledge and you can get more interaction. So by I'm expecting to see you guys later in the day for statistical computing. I will try to connect for that class also. I'll schedule that class so that we can move on faster. Okay, for an introductory class, I am comfortable this way. You can use this. You can use this for a start today, and then we can continue on. So I hope to get feedback from you before my 2 minutes ends.
Okay. Sorry.
I didn't talk. I didn't. You have to talk. I'm done. I didn't know. So if you have anything to say, and you say it now, and before we end. I am already done.
Yeah. Mr. I just want to say something. I can see only both of us, Khalid Maki and I,
having the class with you, and
most of our colleagues are unable to have access to internet facility. So I don't think let me see. Only two of us are beneficial towards this class.
Okay. Yes. Kisatu was online, and Batui also, they have been online. They are very good. It's just that this is unrecorded. So when I'm done, I'll send a tape so that people that cannot afford internet facility at the moment, when they have internet facility, they can go through the channel and get the content there. I'm going to upload this one.
Okay, sir. That's good.
Yeah. So, gentlemen, yeah, that's the case. I'm going to end this class now, and I'll upload the content to the channel, and I will come the other classes. I will improve on. Maybe,
Mr. Selusa.
Yeah. Yes. I'm listening, Kisatu. Yeah.
About the notes, I wanted to suggest if we can have the notes.
Yes, definitely. In the next class, you all get the notes before the next class. I'm starting next week. You get the notes. Okay, you get the notes.
Okay, sir.
I'll work on it. The note is already here, but you normally have to improve on your notes. Not the same you give to the previous years, and then the same. Same for time series. Oh, sorry, for statistical computing. I want to see how we can improve on the notes and use data that is very, very relevant to your work. Okay.